Unit 13, Day 1. Notes solving systems of equations by graphing. Okay. Just as we talked about with inequalities, systems just means you have more than one equation, okay, or there's more than one inequality in our case. Well, what we're going to be dealing with for quite some time now is a system of equations. So we're going to have two graphs potentially, maybe more, usually just two, on our graph. And we're going to have to figure out where the solutions are. Okay, so we have three possible types of solutions to a system. The first is what we have right here, one solution. Okay, now the solution is this point right here, where they intersect. So possible they intersect just once. It's also possible that they are two parallel lines, same slope, so they never intersect, and so therefore there is no solution. And occasionally you might see the word inconsistent for this. Inconsistent. Okay. Third possibility you can have is this one, and you really can't tell, but there are two lines there. There are two lines there. They just happen to lie one right on top of the other. So in this case, we would say we have infinitely many solutions. And that's because these two lines intersect everywhere. There, at any point you go, they're both there. Okay. Now a couple of words you might see for this occasionally are coincident, meaning the lines coincide, or consistent. Occasionally you might see this, so be prepared that they might show up in a word problem or something. All right, let's look at some examples. Okay, determine the solution of the system of equations by looking at the graph. So what we need to do is find the intersection. So in this case, pretty obvious, we have one point right there. So our solution is, let's see, 2, 6. It's an ordered pair, so make sure you put the parentheses and the comma there. Okay, number 2, the solution is over here at -3, -1. So there we have that. Okay, number 3, well, you know what? I don't see a place where these two intersect, and in fact, they are not going to. So this one is no solution. Okay. Okay, so starting at number 4, solve each system by graphing. So first I'm going to try to graph this one right here. So let's see, starting at 1 up 2 over 1. Down 2 over 1. All right, so there's line 1. Line 2, starting at 4, it's a -1 slope. Okay. And the question is, where do they intersect? That's where the solution is. Well, ought to see it right there. Jump out at us, so 1, 3. One, 3 is our solution, because the solution is the intersection point. Okay, number 5. Start by graphing this, so start at -3. Okay, -3. Slope is 1/2, so up 1 over 2, up 1 over 2. Okay. Now my points are it's really important that the points are all here, because that's how I'm going to tell where my line is. Okay, and the next 1/2 x plus 2. 2. All right. Now, if you have those two side by side, you notice something kind of strange. They don't intersect. There is not a point they have in common. So that would be, for us, no solution. All right. All right. Solve each system by graphing. Solve for y if necessary. All right. So in order to graph, we have to make sure y is by itself. So for this one, we don't have to worry about it. Okay. Negative 1/3 x plus 5. Well, let's see. I can actually go ahead and graph that one. Negative 1/3 x plus 5. So it starts right there. Down 1/3. Down 1/3. Okay. Okay, and it's going to go somewhere off in this direction. Okay, so there's the first one. Now for the second one, I want to get y by itself, so I'm going to divide, I want the y by itself, so I'll divide by 3. Divide everything by 3, actually. So I get y is equal to, it's negative 1, negative 1/3 x plus 5. Now, that should appear to you slightly strange, because we've already graphed negative 1/3 x plus 5. Well, since those two are the exact same, we don't really have to graph it because they're really the same exact line. So our solution is going to be infinitely many solutions. There are lots of them. Anywhere on this line is a solution to both of them because they're both the same equation. Okay. Number 7. See, we can graph that first line easy. Second one, let's get y by itself. All right. So let's see, starting at 1, and it's negative 1/2. Okay. Okay, so my line is not perfect. Close enough. All right, now the second one, I want to get y by itself, so I'm going to box in my y term. Subtract 3x, which leaves us with negative 2y, it's negative 3x minus 10. Dividing by negative 2, I get y equals 3/2x plus 5. All right, so start at plus 5, 3/2 is up 3, over 2, or down 3/2. All right. Okay. And as I said before, the points are kind of what matter because that's how we're going to see where these two intersect. Because they intersect right there, which is at negative 2, positive 2. Negative 2, positive 2. And that's our point. Okay. All right, moving on to the next one, we've got number 8. All right, so let's see. First one, y is already by itself, so I'm going to go ahead and graph that first one. Start at 2, up 1/5. Okay, if you use your straight edge. Perfect line there. Second, we need to get y by itself. So there's y minus 2 from both sides. So y equals x minus 2, or 1x minus 2 if you prefer. So it's 2, slope 1. And right there, if you notice as I'm graphing it, place where those two colors meet. That has to be our solution. Alright, so go ahead and finish graphing it there, but our solution, we've already seen, is 5, 3. 5, 3. Alright, let's do this next one. Okay, we have x equals 3, which I know offhand, I'm familiar with Hoy-Vux, as are you. X equals 3 tells us it's going to be a vertical line. Vertical line. So I'm going to have a vertical line that goes through 3. Okay, and this one right here, I need to just get y by itself. So I'm going to box in the y term, divide by 2. And I'm also going to rearrange it, by the way. I'm going to have y equals negative 3x plus 2. So for that one, I'll start at plus 2, down 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3, 2, 3 over 1. Okay, and these two don't right offhand intersect, but I need to continue this line on. It keeps going that way. So they intersect right here at the point. I know that it is x is 3. It's at 3, negative 7. Continuing where we left off, fill in the following tables to determine the solution of each system of equations. Okay, so on number 10 we have these two equations. They're already in standard form, or y-intercept, slope-intercept form. So we can just go ahead and graph those straight the way they are. So if I type these in my calculator, which I've actually got my NSPY right here, okay, if I type those in, okay, so I have y equals negative 2x plus 7, and I'm going to hit tab to graph another one, and I type in y equals 3x minus 8. All right, so I can hit tab in between these two in order to graph another one. So you can graph two equations by using tab. And then I want to do Control T for my table. Control T for my table. Now, if I pull that up, I want to make sure I can see both of those in the same grid. Now, I'm just going to go ahead and write down what I see because our answer is actually displayed for you right there. Your table on your calculator should look like this. 1, 5, negative 5. 2, 3, negative 2. 3, 1, 1. 4, negative 1, 4. Okay, so what this is showing you is the values as you go. So here are x's and here are y's. So for instance, on this first equation, negative 2x plus 7, 1, 5 is a point on that equation. And for the second one, 1, negative 5 is a point. Okay, so what we were actually looking for is the point where these two things cross, right? We're there at the same point at the same time. So if you look in our table, really what we're looking for is when the y values are the same. Well, that is going to be this one right here, 3, 1, 1. Okay, which tells us our solution is 3, 1. Okay, so for number 11, we have a little bit more work to do because we need to get y by itself first. All right, so let's take this one right here. If I want to get y by itself for this one, actually I better write that over here. So I want to get the y term by itself. So I'll add 4. Since these two are like oil and water, they can't go together. Bring it down. And divide by 2. So the equation of my first one is actually y equals 3x plus 2. Okay, that is y equals 3x plus 2. Okay, now the second one, to get y by itself, you actually have to add 3x, so y equals 3x minus 4. So these are two equations I'm going to graph. Okay, so on my calculator, I'm going to doc B to clean that off. 3x plus 2, tab 3x minus 4. Control T. All right, and here's what my table looks like. Let's see, I have 1, 2, 3, 4, 5, negative 1, 8, 2, 11, 5, 14, 8. Okay, now if you look at your graph, you should notice something kind of weird. Those two lines actually look parallel, and in fact, looking at their slopes, they are parallel. What does that mean for our solutions? Well, parallel lines are inconsistent or no solution. Okay, so if you notice, there is no place where these y values are the same. Now I could go looking and I could scroll up, scroll down, and I shouldn't ever find a point where these two are the same. All right. Let's see if we can do this for number 12. We'll need to get y by itself for each of those lines. So let's see. So I would have to divide by 3. I can't graph them unless I get y by itself. So y equals 4/3 x plus 4. And then let's see down here, I'm going to have to add 4 to both sides. Those two are oil and water, they can't go together, so y equals 4/3 x plus 4. Well, it ought to appear pretty obvious to you. These two are the exact same line. So I can already tell you what the solution is. It's actually going to be infinitely many solutions. Infinitely many solutions. Because those two are just like they look like. They're the exact same line. The exact same line. So wherever one is, the other one is also. So 4/3 x plus 4. And I'm just going to go ahead and fill in the table. All right. And let's see. Another one. All right, so I got 1, 5.3, 5.3, and those are actually repeating. 2 is 6.6 repeating for both of them. 3, 8, 8. Let's see, 4, it's 9.3 repeating, 9.3 repeating. But the point is, if you look for where they have the same y values, they're all the same. So there are lots and lots and lots of solutions to that. Okay. All right, 13. Again, we're looking for where there's a solution to the system of equations. So where they have the same point, same x, same y. Okay, well, negative 4 isn't over here. So let's see, negative 1, that's not in the x column. 2, 5, 5's over here. And so we've got these 2 points right here. 5, 11, 5, 11. Are those the same point? Absolutely. So which point represents the solution? Well, 5, 11. Bingo. Okay, now 14, again, we're looking for the same thing. So let's see, negative 3, 5. Nope, different y values, not the same point. Negative 1, not on there. 0, 1, not on there. 2, 5. Ooh, that one's not on there either. Okay, so I'm going to have to kind of fill in the blanks here. So if you notice, these two skip. This one goes, let's see, negative 3, negative 2. It skips negative 1, skips 0. So we're going to have to fill in what those are. We can kind of use the pattern here. So here from negative 3, so a negative 2 is in here somewhere. Let's see, and then a 1 is in here somewhere. Well, halfway between these two is negative 3. Halfway between these two is positive 3. So either of those two works. So negative 2, negative 3, no. 1, 3. Ah, there we go. 1, 3 is actually we had to put in there, and it's on both of these. Sometimes you have to fill in the blank, sort of. You could figure out the equation of the line, graph it, and you could use that as well, but sometimes it's a little easier just to fill in the blanks there. So what's the y value of that solution? The solution there is 1, 3. So the y value is 3. Okay. All right, 15. How many solutions of the system of equations y equals 3x plus 1 and y equals negative 2x minus 4 have? Okay, so if you graph these two, remember they can either be parallel where they don't intersect at all. Okay, we can either do that where they are parallel. That would be 0 solutions right there. I'm trying to give you a visual here. One solution where they intersect once, or they could be the exact same line and be infinitely many. Notice we have never talked about something having two solutions, so 2 is automatically out. But the question for you is, are these the same line? That should be a really obvious question. Is they the same line? Absolutely no. They are not. So they can't be infinitely many. Are they parallel? To be parallel, I mean they have the same slope. Those are positive 3, negative 2, not even close. So not A, it's B. So graph it and double check that. Okay. All right, let's see. The equations of two lines are 6x minus y equals 4 and y equals 4x plus 2. What is the value of x? Value of x in the solution for the system. So I need to actually solve the system right here. All right, well, I'm going to cut to the chase a little bit and show you that this is going to be, see, that's going to be y equals, if I get y by itself, y equals 6x minus 4. And y equals 4x plus 2. All right, so I'm going to go ahead and graph these. Although you'll see in a few days there's actually multiple ways to solve these. So if I graph that one, 6x minus 4, tab 4x plus 2. All right, go to my table. Looking where the y values are the same. Bingo. I get the point 314 on both of these. So the value of x in that solution is 3. And there we go.